Have you ever thought that a solar storm millions of kilometers away from Earth could be the underlying cause of wildfires in Los Angeles? Los Angeles at night. The city lights seem to give way to another scene. A blazing red sky, billowing black smoke spreading like a curtain obscuring everything. Intense wildfires are raging, devouring forests, hills, and even lonely houses nestled in nature. Have you ever wondered why Los Angeles, a glamorous city renowned worldwide, repeatedly falls victim to such devastating wildfires? What's the root cause? Global warming, arid climates, or is there something else happening that we have yet to realize? We all know that wildfires are not unfamiliar in California, especially Los Angeles, where scorching weather and powerful Santa Ana winds create the perfect conditions for fires to spread rapidly. But there's an unsolved mystery behind these disasters, an unimaginable link between an astronomical phenomenon millions of kilometers away from Earth and these catastrophic wildfires. That phenomenon is solar storms. Imagine this: millions of light years away, on the surface of the largest star in the solar system, massive plasma eruptions occur, releasing powerful streams of charged particles into space. These streams, upon nearing Earth, not only affect satellites or power systems, but can also alter the atmospheric environment, triggering unexpected domino effects. But the question is, how can those tiny particles, originating from a sun 150 million kilometers away from Earth, contribute to wildfires in a city located on the western coast of the United States? Modern science has begun to decode this mystery, and the answer lies not merely in distance or isolated physical phenomena. It all starts with a series of complex interactions involving Earth's magnetic field, the atmosphere, and particularly the natural elements unique to Los Angeles. In recent years, scientists have identified a strange correlation. Powerful solar storms often coincide with the occurrence of major wildfires in California. The story doesn't end with numbers or hypotheses. Looking back in history, from the Carrington event in 1859, the largest recorded solar storm, to recent incidents like the 1989 solar storm that caused a massive blackout in Quebec, Canada, these events have left severe global consequences. Los Angeles, with its unique geographic position and hot, dry climate, can be considered a hotspot most vulnerable to such impacts. Solar storms are not something we can see with the naked eye, yet their effects are widespread and silently influence our daily lives. Charged particles from the sun can alter Earth's magnetic field, causing geomagnetic storms and extreme space weather phenomena. In Los Angeles, the Santa Ana winds, dry, hot, and strong, can also be influenced by atmospheric changes caused by solar storms. This not only increases the risk of wildfires, but also makes them spread faster and harder to control. What truly makes this story captivating are the latest scientific findings. Researchers at NASA and Stanford have published reports showing that over 60% of major wildfires in California coincide with periods of heightened solar activity. They also discovered that increased ionization in the upper atmosphere can cause minor yet significant changes in regional weather conditions, especially in sensitive areas like Los Angeles. So, is this a warning from the universe? Are we entering an era where macro-astronomical phenomena begin to interfere more profoundly in our daily lives on Earth? Or are these merely coincidences that have yet to be fully explained? The journey to uncover the link between solar storms and wildfires in Los Angeles is not just a tale of science, but also an exploration of realms beyond human understanding. In this video, we will delve into every aspect of this issue, from complex physical phenomena to heart-wrenching real-life stories, to find answers to the big question: what can we do to protect Earth and ourselves from these uncontrollable events? Get ready, because what you're about to discover will change the way you view the world around you. Solar storms, phenomena, and their impact on Earth. Solar storms, one of the most powerful phenomena in outer space, originate from the surface of the Sun, where magnetic and energetic activity takes place intensely. The Sun is not merely the source of light and heat that we experience daily, but also a massive reactor generating endless energy from plasma eruptions. These eruptions, often referred to as solar storms, occur when magnetic fields on the Sun's surface become unstable, leading to the sudden release of a vast amount of energy. This powerful explosion produces enormous plasma waves, releasing immense heat and light, while emitting a massive amount of charged particles into space. These charged particles, known as CME, coronal mass ejections, travel at staggering speeds of up to millions of kilometers per hour, heading directly toward Earth or other planets in the solar system. A CME is a massive plasma cloud containing charged particles, including protons and electrons, propelled out of the Sun's atmosphere by the energy from these eruptions. When these CMEs collide with Earth's magnetic field, they can cause significant changes, such as geomagnetic storms, disruptions in the atmosphere, and impacts on our planet's technological systems. Interestingly, solar storms do not occur randomly, but are often associated with the Sun's 11-year cycle, a period during which solar activity peaks and then gradually subsides. During each cycle, the Sun transitions from quiet phases to intense activity, with the appearance of more sunspots signaling an increase in eruptions and CMEs. Notably, in recent years, scientists have observed a significant rise in the frequency and intensity of solar storms. This may indicate changes in solar activity or reflect the influence of cosmic factors that we have yet to fully understand. To illustrate, let's revisit history. One of the most famous events is the Carrington event of 1859, the strongest solar storm ever recorded. At the time, an extremely powerful CME struck Earth, causing spectacular auroras visible in many places, even in tropical regions. Remarkably, the global telegraph system of that era experienced severe disruptions, with sparks flying from cables and machinery catching fire. More recently, in 1989, another solar storm caused a massive blackout across the province of Quebec, Canada, affecting millions of people. These events not only underscore the power of solar storms, but also highlight our reliance on modern technology and its vulnerability to astronomical phenomena. Recent data further reinforces concerns about the impact of solar storms. According to NASA, solar eruptions have increased by 15% in the current solar cycle compared to the previous one. This means we face a higher risk from the effects of solar storms, not only on technology, but also on Earth's atmosphere and environment. Despite being 150 million kilometers away, the Sun has the potential to profoundly influence the green planet, both in the past and the near future. Given all this, solar storms are not just an astronomical phenomenon we should know about, but also a reminder of the inseparable connection between Earth and the universe. Understanding them better not only helps us predict and mitigate potential damages, but also opens opportunities to delve deeper into the unsolved mysteries of the solar system. How do solar storms affect Earth's magnetic field? When solar storms occur, they generate powerful streams of charged particles that speed toward Earth at millions of kilometers per hour. Upon interacting with our planet's magnetic field, these streams of particles not only engage with atmospheric layers, but also cause geomagnetic storms, a significant disturbance in Earth's magnetic field. The magnetic field, which serves as a natural shield against cosmic radiation, becomes destabilized when struck by particles from solar storms. Geomagnetic storms are not just complex physical phenomena, they also produce significant consequences that impact both the natural environment and human life. During geomagnetic storms, Earth's magnetic field undergoes intense fluctuations, leading to phenomena we often recognize as auroras, the colorful lights seen in polar regions. However, behind this mesmerizing beauty lies a concerning reality. Geomagnetic storms can disrupt modern technological systems that our society heavily depends on. Specifically, they can interfere with GPS signals, affect satellite operations, and even damage high-voltage power lines. This occurs because charged particles from solar storms, upon colliding with Earth's atmosphere and magnetosphere, can generate powerful induced currents across the planet's surface. These currents have the potential to overload electronic devices and cause severe damage to infrastructure systems. One prominent example of solar storms' impact on Earth's magnetic field and technology is the Carrington event of 1859, the largest solar storm ever recorded in history. During this event, an enormous coronal mass ejection, CME, struck Earth directly, triggering intense geomagnetic storms. Auroras were so bright that they were visible even in tropical regions, leading many to mistake them for sunlight at dawn. However, its effects extended far beyond this natural spectacle. The storm severely disrupted the global telegraph system, the most advanced technology of the time. Telegraph wires sparked, telegraph stations were destroyed, and many telegraph operators received dangerous electric shocks while working. More recently, in 1989, another solar storm caused significant damage in Quebec, Canada. Induced currents from the geomagnetic storm overwhelmed the power grid, resulting in widespread blackouts that affected millions of people for several hours. The economic loss from this incident was estimated to be billions of dollars, not to mention the indirect impacts on people's lives and regional economic activities. In addition to power grids, geomagnetic storms also significantly impact Earth-orbiting satellites. Although satellites are designed to operate in the harsh conditions of space, they remain vulnerable to high-energy particles from solar storms. Increased fluxes of charged particles can heat and expand the upper atmosphere, causing satellites to encounter greater drag, which can lead to orbit deviations or reduced operational lifespans. Furthermore, GPS signals, a technology we rely on daily for navigation and positioning, can be disrupted or completely lost during strong geomagnetic storms. This poses particular risks to the aviation industry, maritime navigation, and military operations, where GPS accuracy is critical. Electronic devices on the ground are not immune to these effects either. Transformers, power grid control systems, and even medical equipment in hospitals can be damaged by induced currents from geomagnetic storms. This is why experts emphasize the importance of strengthening infrastructure against the risks posed by cosmic phenomena like solar storms. Looking at the bigger picture, Earth's magnetic field acts as a shield protecting us from harmful cosmic impacts. However, when struck by solar storms, this protective layer becomes unstable, triggering complex reactions that affect both the natural environment and technological systems. While we cannot prevent solar storms, understanding them better allows us to mitigate risks and safeguard critical systems and lives on Earth. The Carrington event and the 1989 solar storm are just two striking examples of the immense power of solar storms and their far-reaching impacts on Earth's magnetic field. They serve as reminders that, in a world increasingly reliant on technology, we cannot ignore the threats from outer space. We must continue researching and developing protective measures to ensure that future geomagnetic storms do not disrupt humanity's rhythm of life. The impact of solar storms on Earth's atmosphere. Solar storms not only affect Earth's magnetic field and modern technology, but also cause significant changes in the atmosphere, especially in the upper atmosphere, where high-energy solar particles directly interact. When these streams of particles collide with the upper layers of the planet's atmosphere, they create intense ionization. Ionization occurs when charged particles from solar storms strike atmospheric gas molecules, releasing electrons and generating ions. As a result, the upper atmosphere becomes more active, with a sudden surge in ion and electron density. This increase in ionization can trigger a chain reaction throughout Earth's atmosphere. Ionized molecules have the potential to disrupt radio wave propagation, causing interruptions to global communication systems. Additionally, strong ionization enhances thermal radiation within the atmosphere, leading to changes in temperature and pressure. These alterations are not confined to the upper layers, but can propagate downward, causing long-term effects on regional weather and climate. One major consequence of solar storms is the creation of space weather, a term used to describe the impact of cosmic events on the environment around Earth. Charged particles from the Sun amplify activity in the atmosphere, leading to significant changes in airflows and the structure of the thermosphere. This can alter global wind patterns, affecting the distribution of temperature and humidity, and resulting in localized weather shifts. A notable example of space weather's effects is the Santa Ana winds in California, particularly around Los Angeles. While these winds primarily form due to local geographical and climatic conditions, scientists have indicated that increased ion density in the atmosphere caused by solar storms can alter the wind's characteristics, making them stronger and drier, thereby heightening the risk of wildfires. This serves as a clear demonstration of how cosmic phenomena can interact with Earth's natural elements, leading to unpredictable consequences. NASA's research has provided further evidence of the connection between solar storms and weather changes on Earth. According to reports from NASA's Space Weather Prediction Center, periods of intense solar activity often correlate with temperature increases in the upper atmosphere, causing it to expand and triggering cascading effects on lower layers. Another study by NASA's timed probe found that major solar storm events could significantly increase heat density in the thermosphere, altering the global structure of the atmosphere for days or even weeks. Furthermore, some scientists have warned that solar storms may contribute to extreme weather events, such as hurricanes, droughts, or abnormal heavy rainfall in certain regions. While these effects may not directly cause such events, the additional energy introduced into the atmosphere by solar storms can amplify existing weather conditions, making them more severe. For instance, during the period from 2003 to 2012, a cycle of heightened solar activity, the frequency of global extreme weather events increased by about 20% compared to the previous cycle. According to data from the World Meteorological Organization, WMO. The most concerning aspect, however, is that atmospheric changes caused by solar storms may not be confined to short-term effects. Increased energy in the upper atmosphere and shifts in global aerodynamic patterns could contribute to altering Earth's thermal balance, with long-term implications for the climate. This underscores the urgent need for research and forecasting of solar storm impacts, especially in the context of global climate change. In conclusion, the impact of solar storms on Earth's atmosphere is a complex phenomenon with multidimensional consequences. From intensifying ionization in the upper atmosphere and altering airflows to causing regional weather changes, solar storms affect not only physical factors, but also pose significant challenges for humanity in understanding and responding to these changes. Scientific studies increasingly reveal that the connection between outer space and Earth extends beyond mere distance to include profound and unpredictable effects that we must continue to explore. Los Angeles, a hotspot for wildfires and natural conditions. The climate characteristics of Los Angeles. Los Angeles, famous for its bright sunshine and beautiful beaches, is situated in a characteristic Mediterranean climate zone, where summers are hot and dry, while winters are mild with minimal rainfall. This climate, though providing a picturesque allure that attracts millions of tourists annually, also harbors unpredictable natural risks, particularly wildfires. Summers in Los Angeles are often prolonged and intense, with soaring temperatures. Over the past decade, scientists have recorded that the average summer temperature in the area has risen by 3 to 5 degrees Celsius, a concerning figure. Global climate change is contributing to this temperature increase, making Los Angeles one of the most vulnerable regions to wildfire risks. Another natural factor elevating the wildfire risk in Los Angeles is the Santa Ana winds, dry, hot, and strong winds that occur periodically in fall and winter. These winds blow from inland desert regions toward the coast through narrow valleys, carrying extremely dry air and driving humidity levels to extremely low thresholds. Santa Ana winds not only increase temperatures, but also enable small fires to spread uncontrollably in a very short period. This is why authorities consistently warn of heightened wildfire risks whenever the Santa Ana winds occur. However, the Santa Ana winds are not the sole factor making Los Angeles prone to wildfires. Prolonged drought and the accumulation of flammable vegetation create ideal conditions for fires to ignite. Each summer, rainfall in Los Angeles often drops to minimal levels, leaving vegetation parched. Dry trees, grasses, and fallen leaves form a dense layer of natural fuel, ready to ignite with just a small spark. Combined with high temperatures and low humidity, the wildfire risk not only increases, but also becomes significantly harder to control. Statistical data shows that average annual rainfall in Los Angeles has significantly declined over the past 50 years, exacerbating regional drought conditions. Forests surrounding the city have gradually turned into ticking time bombs, waiting for triggers such as strong winds, lightning strikes, or sparks from human activities to erupt into massive fires. Furthermore, rising temperatures make the air drier, pushing humidity to extremely low levels, making already arid areas even more flammable. A clear example of this was the 2020 wildfire season, during which Los Angeles faced a series of severe fires. Extreme weather, combined with strong Santa Ana winds and parched vegetation, turned small blazes into megafires, spreading thousands of hectares within hours. These fires not only caused significant property damage, but also inflicted heavy environmental losses, destroying ecosystems and releasing massive amounts of CO2, further contributing to global climate change. Climate change has not only raised temperatures, but also extended the wildfire season. In the past, wildfire season in Los Angeles typically lasted from May to October. However, with rising temperatures and prolonged droughts, fires can now occur at any time of the year. This has made Los Angeles one of the most prominent wildfire hotspots, not only in the United States, but also globally. In summary, Los Angeles's climatic characteristics, hot, dry summers and strong winds, have created an ideal environment for wildfires to thrive. When combined with climate change and inherent natural conditions, the wildfire risks in this region continue to rise, demanding heightened vigilance and more effective preventive measures. Data on rising temperatures and declining rainfall serve not only as warnings, but also as reminders that immediate action is required to protect the environment and mitigate the risks posed by nature. Causes of wildfires in Los Angeles. Wildfires in Los Angeles are a complex phenomenon with intertwined causes, including both natural factors and human activities. Naturally, this area encompasses all the conditions that easily ignite and spread fires. Lightning, especially during dry thunderstorms, is one of the common causes. Lightning strikes can ignite dry vegetation, quickly turning it into large wildfires, particularly when no accompanying rain is present to extinguish the flames. Additionally, prolonged droughts are a serious issue in Los Angeles. In recent years, average rainfall has decreased significantly, leaving trees, weeds, and other plants dry, and making them ideal fuel for wildfires. Furthermore, the Santa Ana winds, dry, strong winds that typically occur in the fall and winter, act as a perfect catalyst, not only accelerating the spread of fires, but also making them far more difficult to control. However, natural factors are not the only cause. Human activities also significantly contribute to wildfire risks. Urban expansion in Los Angeles has increased forest encroachment, situating many residential areas right next to fire-prone forests. This not only poses risks to residents, but also increases the likelihood of humans unintentionally or intentionally sparking fires. Activities such as uncontrolled campfires, trash burning, or even careless cigarette disposal can all trigger fires. Another concerning factor is the electrical infrastructure. In many cases, high-voltage power lines damaged or short-circuited by strong winds have created sparks, igniting major wildfires. A prime example of the impact of both natural and human factors is the 2018 Woolsey Fire, one of the most devastating wildfires in California's history. This fire, which began in November of that year, was believed to have been caused by a malfunction in the electrical system of a major energy provider. Combined with strong Santa Ana winds, the fire spread at an alarming rate, burning over 39,000 hectares of land and destroying more than 1,600 structures. The consequences were not only economic damages exceeding $5 billion, but also significant environmental and human losses. Many residents were displaced, hundreds of wildlife species lost their natural habitats, and the CO2 emissions from the fire further exacerbated the issue of climate change. Furthermore, frequent human interventions in the natural environment, such as deforestation, road construction, or large-scale building projects, also increase wildfire risks. These developments not only degrade natural ecosystems, but also remove buffer zones that help prevent fires from spreading. Moreover, construction materials like wood, plastic, and fuel used in residential areas near forests can easily catch fire, allowing wildfires to quickly spread from forests into populated areas. In reality, the risk of wildfires in Los Angeles does not stem from isolated causes, but rather the combination of multiple factors. The interplay between natural conditions and human activities has created an environment highly susceptible to large fires. Additionally, global climate change has been exacerbating these factors. Rising temperatures, prolonged dry seasons, and extreme weather events not only increase the risk of wildfires, but also make them more dangerous and harder to control. To mitigate the impact of wildfires, authorities must enhance forest management, improve infrastructure, and raise community awareness about wildfire prevention. Combining scientific measures, effective policies, and practical actions can help Los Angeles reduce the risk of wildfires while protecting the environment and the lives of residents in the area. The impact of climate change on wildfires. Climate change is significantly increasing the risk of wildfires in Los Angeles, both in terms of frequency and severity. One of the most evident consequences of this phenomenon is the intensification of prolonged droughts, leaving forests and vegetation in the region drier than ever. Drought not only reduces soil moisture, but also dehydrates trees, turning them into ideal fuel for fires. According to statistics, over the past 30 years, average rainfall in this area has dropped by up to 20%, resulting in drought conditions affecting over 90% of forested land. Forests, once the green lungs of the city, have now become fuel storage, waiting for a spark to ignite. Prolonged drought also means that natural water sources are depleting, reducing the ecosystem's ability to self-regulate when facing wildfire risks. In addition to exacerbating drought conditions, climate change also accelerates the spread of wildfires by increasing the frequency of extreme weather events. Higher temperatures, combined with strong winds such as the Santa Ana winds, create perfect conditions for fires to spread rapidly and become harder to control. As temperatures rise, the air becomes drier, pushing humidity to extremely low levels, making everything more flammable. Research shows that for every 1 degree Celsius increase in average summer temperature, the risk of wildfires increases by approximately 20%. This means that Los Angeles, already affected by a hot and dry climate, is facing an ever-growing threat of severe wildfires. Moreover, extreme weather conditions like strong winds and high temperatures not only accelerate the spread of fires, but also make extinguishing them more challenging. Fires can spread so rapidly that they surpass the response capabilities of firefighting forces, with blazes driven by strong winds leaving little time for evacuation or property protection. In fact, the increase in severe wildfires in California in recent years has largely been associated with extreme weather events fueled by climate change. To illustrate, the 2020 wildfire season stands out as one of the worst in California's history, including Los Angeles. Record-high temperatures, prolonged droughts, and the presence of strong winds caused fires to ignite and quickly engulf more than 1.7 million hectares of land. Notably, the August Complex Fire, considered the largest megafire in California's history, destroyed thousands of homes and forced large-scale evacuations. Furthermore, climate change not only affects the frequency and severity of wildfires, but also alters their timing. In the past, wildfire season in Los Angeles typically lasted from May to October. However, due to climate change, the risk of wildfires now persists year-round. With increasingly extreme weather conditions, fires are not only becoming more frequent, but also harder to predict, complicating prevention and response efforts. The consequences of wildfires extend beyond physical damage, causing significant losses to the environment and global climate. Every major wildfire releases millions of tons of CO2, exacerbating the greenhouse effect. At the same time, the loss of forests reduces the ability to absorb CO2, disrupting the natural climate cycle. Research from the National Oceanic and Atmospheric Administration, NOAA, indicates that major wildfires in California over the past decade have increased the United States' annual CO2 emissions by approximately 5%. A significant figure as the world strives to reduce emissions. Overall, climate change is making wildfires in Los Angeles a greater challenge than ever. From intensifying droughts and driving extreme weather events to exacerbating environmental damage, these factors intertwine and amplify each other, creating a difficult cycle to break. To mitigate the impact of climate change on wildfire risks, authorities must strengthen forest protection, improve water management, and enhance research to better predict and respond to unusual weather phenomena. Only by doing so can we protect Los Angeles and other vulnerable regions from the growing threats posed by climate change. The link between solar storms and wildfires. Solar storms' impact on atmospheric conditions in Los Angeles. Solar storms, despite occurring millions of kilometers away from Earth, have the potential to profoundly affect our planet's atmosphere, particularly in sensitive areas like Los Angeles. One of the most notable impacts is the increase in atmospheric ionization. When streams of charged particles from the Sun, CME, coronal mass ejections, collide with Earth's upper atmosphere, they enhance ionization levels, creating a highly energized environment. This ionized layer not only affects communication signals and technology, but also directly impacts temperature and wind distribution in the region. Air temperatures rise as high-energy particles collide with atmospheric molecules, causing expansion and pressure changes in the atmosphere. These changes can trigger regional weather alterations, making Los Angeles, already affected by a dry climate, hotter and more vulnerable to wildfire risks. Another significant impact of solar storms is their ability to alter atmospheric aerodynamic flows. When the ionized layer is stimulated, air currents in the upper atmospheric layers are disrupted. This can result in major changes in global and regional wind patterns. In Los Angeles, this effect is particularly evident with the Santa Ana winds, dry, hot winds that blow from the desert through canyons to coastal areas. Under the influence of solar storms, the Santa Ana winds can become stronger, carrying drier and hotter air, accelerating the spread of wildfires. Studies have shown that during periods of strong solar storms, the risk of wildfires in Los Angeles increases significantly, with fires spreading faster and becoming harder to control. Additionally, aerodynamic changes induced by solar storms can trigger other extreme weather phenomena. Unusual airflows can cause sudden gusts or increase the frequency of dry wind events. This is particularly dangerous in Los Angeles, where the Mediterranean climate already provides ideal conditions for fire outbreaks and rapid spread. When winds grow stronger, dry and hot air is blown across areas with flammable vegetation, hastening ignition and transforming small fires into massive wildfires. Scientists have conducted extensive research to clarify the link between solar storms and local atmospheric changes in regions like Los Angeles. A NASA study revealed that during periods of intense solar activity, upper atmospheric temperatures rise significantly, leading to atmospheric expansion and altered airflows. This not only affects the upper atmospheric layers, but also directly influences regional weather phenomena. A report from the University of California highlighted that strong and dry winds in Los Angeles, including the Santa Ana winds, tend to intensify during peak solar storm cycles. This connection is not merely a fascinating natural phenomenon, but also presents significant challenges for wildfire prevention efforts. With atmospheric disturbances and increasingly extreme weather conditions, predicting and controlling wildfires becomes more complicated than ever. Furthermore, with solar storm frequencies expected to rise in upcoming solar cycles, Los Angeles may face even more severe wildfire risks, both in terms of frequency and scale of devastation. Solar storms are not just distant astronomical events, but also significantly impact atmospheric conditions in Los Angeles. From enhancing ionization levels and altering aerodynamic flows to triggering extreme weather phenomena like the Santa Ana winds, solar storms play a crucial role in increasing wildfire risks in the region. These impacts not only make Los Angeles one of the hotspots for wildfires, but also highlight the urgent need for research and response strategies to address atmospheric and space weather-related phenomena. Geomagnetic storms increase wildfire risks through power systems. Geomagnetic storms, a consequence of solar storms when charged particles from CME, coronal mass ejections, collide with Earth's magnetic field, not only produce natural phenomena like auroras, but also have severe impacts on modern technological infrastructure, especially power grids. When geomagnetic storms occur, Earth's magnetic field is significantly disturbed, creating induced currents on the planet's surface. These currents can overload power systems, leading to instability or even damage to electrical equipment. For Los Angeles and other areas in California, where power lines run through vast forested regions, the impact of geomagnetic storms can increase the risk of wildfires. One of the greatest wildfire risks posed by geomagnetic storms is the generation of electrical sparks from high-voltage power lines. When geomagnetic storms strike, currents in power lines can surge abruptly, exceeding the system's load capacity. This not only heats up the lines, but can also cause short circuits and sparks. If these high-voltage lines are near dry vegetation, a common scenario in Los Angeles due to its hot and dry climate, electrical sparks can quickly ignite small fires. Under the influence of strong winds like the Santa Ana winds, these small fires can rapidly spread into massive wildfires. Historical records highlight several instances where geomagnetic storms disrupted power systems, leading to catastrophic consequences. A notable example is the 2003 wildfire in California, which originated from a power grid failure linked to a solar storm. Sparks from high-voltage power lines ignited dry brush below, triggering a rapidly spreading fire. Within a short time, the fire consumed thousands of hectares of forest, destroyed numerous homes, and caused severe economic and environmental damage. This case underscores the vulnerability of power grids and illustrates how geomagnetic storms can initiate wildfire disasters in regions like Los Angeles. The electrical infrastructure in California, including Los Angeles, is designed to supply power to millions of residents, yet it is located in areas prone to extreme weather conditions and astronomical phenomena like geomagnetic storms. When strong winds combine with other factors such as high temperatures and low humidity, even a small spark from the power system can ignite a major fire. This is why many experts warn that improving power grid systems and mitigating risks from geomagnetic storms should be a top priority to protect this region from wildfire threats. Moreover, the impact of geomagnetic storms is not limited to generating sparks. When power grids become unstable, the ability of authorities to monitor and remotely control systems is also compromised. This makes early detection of issues more challenging, delaying responses and fire containment efforts. In many cases, fires caused by electrical sparks in remote areas remain undetected until they have spread beyond control. Los Angeles's location in a dry region with flammable vegetation and power lines running through dense forests exacerbates the severity of the issue. With each new solar cycle, as the frequency and intensity of solar storms are projected to increase, the risk of wildfires caused by power systems affected by geomagnetic storms becomes increasingly evident. Geomagnetic storms are not just astronomical phenomena, but also pose significant threats to the safety of power systems and the living environment in Los Angeles. Improving electrical infrastructure, enhancing load capacity, and mitigating the effects of geomagnetic storms are essential to reducing wildfire risks. At the same time, raising awareness and implementing advanced technologies for monitoring and controlling power grids can help limit the negative impacts of geomagnetic storms, protecting communities from natural disasters. Scientific studies demonstrating the link between solar storms and wildfires. In recent years, scientists have conducted numerous studies to clarify the connection between solar storms and wildfires on Earth, particularly in vulnerable areas like Los Angeles. Reports from NASA, one of the world's leading space research organizations, have provided clear evidence of the correlation between strong solar storms and the increasing risk of wildfires. According to NASA, high-energy particles from solar storms, when interacting with Earth's magnetic field and atmosphere, not only cause intense ionization, but also alter regional weather patterns. These changes, combined with natural factors such as drought and strong winds, create an ideal environment for wildfires to ignite and spread. A specific NASA report revealed that during periods of intense solar activity, characterized by the number of sunspots and CME events, the risk of wildfires in regions like California significantly increases. The report emphasized that ionization from solar storms could disrupt aerodynamic flows and intensify dry, hot winds, such as the Santa Ana winds in Los Angeles. These factors play a critical role in causing fires to spread faster and become more difficult to control during major wildfires. In addition to NASA, researchers at Stanford University have developed simulation models to analyze the relationship between solar activity and wildfire risk. These models focus on recreating atmospheric conditions during periods of heightened solar activity and evaluating how regional weather patterns are affected by solar storms. The results of these simulations indicate that during peak solar cycles, Earth's upper atmosphere becomes unstable, leading to an increase in extreme weather phenomena such as strong winds and droughts. These changes not only raise the risk of wildfires, but also cause them to ignite with greater intensity and last longer. Data from these studies further reinforce this connection. A critical statistic indicates that 60% of major wildfires in California over the past 3 decades coincided with periods of intense solar activity. This is not a random coincidence, but the result of far-reaching effects from solar storms on climate and environmental conditions. Research also highlights that in years when solar activity peaked, such as the 2000 to 2001 and 2012 to 2013 cycles, the number of large wildfires in California and Los Angeles surged dramatically, causing severe damage to property, the environment, and human lives. Stanford scientists also noted that the link between solar storms and wildfires is not merely due to natural factors such as rising temperatures or strong winds, but also relates to changes in the ionosphere and thermosphere. These atmospheric layers, when affected by solar storms, not only disrupt airflows, but also increase pressure on both natural and artificial systems, such as power grids, thereby amplifying the risk of fires. In practice, these studies not only enhance our understanding of the complex relationship between solar storms and wildfires, but also open new approaches for predicting and mitigating risks. Monitoring solar activity and using climate models to forecast high-risk periods can help authorities and firefighting agencies better prepare for wildfires. Additionally, these findings underscore the importance of improving infrastructure and forest management systems to minimize the impact of solar storms on the environment and society. In conclusion, studies from NASA and Stanford University provide solid evidence that the connection between solar storms and wildfire risks is real and concerning. Atmospheric changes caused by solar storms not only impact the natural environment, but also increase climate and wildfire-related risks. A deeper understanding of this relationship will enable us to respond more effectively to the growing challenges posed by both nature and the cosmos. Response measures and future projections. Monitoring solar storms and providing early forecasts are crucial steps to minimize their impact on Earth, particularly in reducing the risk of wildfires and other natural disasters. One of the most powerful tools scientists use to observe solar activity is advanced satellites like SOHO, Solar and Heliospheric Observatory, and Parker Solar Probe. SOHO, a joint project between NASA and the European Space Agency ESA, launched in 1995, has become one of the most important sources of data on solar activity. This satellite can monitor sunspots, predict CME coronal mass ejections, and provide detailed imagery of the solar corona. Such information enables scientists to forecast the timing and intensity of solar storms, allowing authorities to prepare before these energetic particles reach Earth. Meanwhile, Parker Solar Probe, launched in 2018, has ventured closer to the Sun's atmosphere than any previous mission to study phenomena such as solar wind and the Sun's magnetic fields. This satellite not only provides data on how high-energy particles are generated, but also enhances our understanding of their interactions with Earth's magnetic field. The insights from Parker Solar Probe represent a breakthrough in accurately predicting when solar particle streams will affect our planet, thereby safeguarding critical systems like power grids, satellites, and technological infrastructure. In addition to satellite technology, international collaboration in space weather forecasting is equally vital. Solar storms are not confined to a single nation or region, but pose a global concern, as charged particles from the Sun can affect the entire planet. Strengthening cooperation between nations, research organizations, and international space agencies is the most effective way to enhance forecasting capabilities and mitigate risks. Institutions like the Space Weather Prediction Center, SWPC, in the US, ESA, and Russia's Roscosmos have been closely collaborating to share data, research, and modeling tools to improve predictions of solar storm timing and impact. International collaboration extends beyond information sharing to developing joint response strategies. For instance, during periods of heightened solar activity, nations can issue global space weather alerts while implementing measures to protect critical infrastructure, such as shutting down non-essential power grid systems, safeguarding satellites in orbit, and ensuring the safety of astronauts in space. These actions require high levels of synchronization among nations and space agencies to maximize effectiveness. Moreover, organizations like the United Nations play a crucial role in encouraging countries to invest more in space weather research and establish global warning systems. International workshops and training programs on space weather are regularly organized to enhance the capacity of nations to address the effects of solar storms. An example of effective coordination is the SWPC system, where data from NASA and ESA satellites is analyzed to produce real-time space weather alerts. These alerts not only assist infrastructure management agencies, but also provide the scientific community with a better understanding of how solar storms affect Earth. Thanks to this global cooperation, many regions have significantly mitigated damage from space weather events. Monitoring solar storms and early forecasting are essential steps in addressing the risks posed by this astronomical phenomenon. The combination of advanced technology, such as the SOHO and Parker Solar Probe satellites, with international collaboration, not only enhances forecasting capabilities, but also reduces the impact of solar storms on vulnerable areas like Los Angeles. Increasing investments in research and developing global space weather warning systems will be key to protecting humanity and the environment in the future, as solar activity becomes increasingly unpredictable. Addressing the risk of wildfires in Los Angeles, a region where natural and human factors converge to create ideal conditions for fires, requires comprehensive and effective prevention strategies. One of the most critical solutions is managing vegetation and creating fire breaks. With its dry climate and low rainfall, Los Angeles frequently faces forests and vegetation that are highly flammable. Shrubs, dry grass, and fallen leaves accumulate over time, becoming ideal fuel for wildfires. Therefore, removing or controlling these combustible materials is essential in reducing the risk of fire outbreaks. Vegetation management involves pruning trees, removing dry brush, and maintaining safe distances between residential areas and forested regions. These fire breaks not only help prevent fires from spreading, but also facilitate access for firefighting teams to control fires when they occur. Areas such as Griffith Park and the Santa Monica Mountains, which have dense vegetation, have successfully implemented firebreak programs, significantly reducing the risk of fires spreading into nearby residential areas. Additionally, encouraging households to use fire-resistant or less flammable plants in landscaping is part of the local wildfire prevention strategy. In parallel with vegetation management, upgrading the electrical system is a critical measure to mitigate risks from solar storms, a natural factor that can trigger wildfires through electrical incidents. The power grid in Los Angeles, with thousands of kilometers of lines running through forested areas, is often affected by extreme weather conditions. Aging high-voltage power lines are prone to generating electrical sparks under the impact of strong winds or geomagnetic storms, a common cause of wildfires. To address this, regulatory agencies have proposed solutions, such as upgrading the electrical system by replacing old lines with heat-resistant and spark-proof conductors. Additionally, utility companies like Southern California Edison have implemented improvement programs, including converting some overhead power lines into underground cable systems in high-risk fire zones. Underground cables not only reduce the risk of sparks, but also protect the power grid from extreme weather events like solar storms or Santa Ana winds. Beyond infrastructure improvements, advanced technology plays a crucial role in enhancing prevention efforts. Modern sensors and temperature monitoring devices installed along power lines can detect potential issues such as overheating or electrical sparks early on. Through these early warning systems, power grid operators and firefighting teams can take preventive measures before incidents escalate into disasters. Furthermore, conducting community awareness campaigns is an essential component of wildfire prevention strategies. Local education programs encourage residents to better understand the risks of wildfires and solar storms and take specific actions to protect themselves and their property. For instance, residents are taught how to maintain safe distances between their homes and forested areas, handle flammable materials around their homes, and respond appropriately to fire warnings. A notable example is Los Angeles' wildfire prevention campaign, which utilizes GIS, Geographic Information Systems technology, to identify the highest-risk areas. Based on this data, forest management, infrastructure protection, and community training measures are prioritized in these hotspots to ensure maximum effectiveness in risk reduction. Wildfire prevention in Los Angeles requires a multidimensional approach, from vegetation management and electrical infrastructure upgrades to community education and advanced technology implementation. These measures not only mitigate risks from natural and human factors, but also better equip the region to tackle increasing challenges from climate change and solar storms. Long-term investment in sustainable solutions not only protects the environment, but also contributes to maintaining the safety and prosperity of Los Angeles. To address the increasingly severe impacts of solar storms and space weather phenomena, moving towards a sustainable future requires coordinated efforts from communities, scientific organizations, and governments worldwide. One of the most critical steps is raising public awareness about the effects of solar storms and how they can directly impact daily life. Solar storms are not merely distant astronomical phenomena, but are closely tied to practical issues, such as power outages, transportation disruptions, and wildfire risks. However, most people remain unaware of the significance of these issues. Community outreach campaigns and education play a key role in bridging this awareness gap. Local governments and environmental organizations can organize workshops, public lectures, or produce engaging, easy-to-understand multimedia materials to help people better understand solar storms, how they work, and their effects on life and the environment. For example, using 3D simulations or real images from satellites like SOHO and Parker Solar Probe can vividly illustrate these phenomena, capturing public attention and interest. Additionally, educating younger generations should be a priority. Integrating knowledge about solar storms and space weather into school curricula can help students gain a deeper understanding of natural phenomena and inspire them to pursue careers in related scientific fields. This not only raises awareness, but also fosters a generation of scientists and engineers capable of developing effective solutions to future challenges. Alongside raising awareness, developing technologies to protect Earth from the impacts of space weather is an indispensable part of the roadmap towards a sustainable future. Technological advancements have opened up many opportunities to mitigate the effects of solar storms, particularly in safeguarding critical infrastructure such as power grids, telecommunications systems, and satellites. One key initiative is the development of early warning systems, enabling authorities to detect and predict solar storms with greater accuracy, allowing for timely responses. Advanced sensors and specialized satellites are being deployed to collect data on solar activity and magnetic phenomena. For instance, satellites like GOES, Geostationary Operational Environmental Satellites, and DMSP, Defense Meteorological Satellite Program, are designed to provide real-time data on space weather phenomena. Using this data, modeling systems can analyze and predict the impacts of solar storms, minimizing damage to infrastructure and the environment. New technologies are also being developed to enhance infrastructure resilience against space weather effects. For example, using spark-resistant materials in electrical systems, upgrading high-voltage power lines, and constructing magnetic shielding systems can reduce risks from geomagnetic storms. New satellites are also being designed to better withstand solar radiation, ensuring the stability of telecommunications and global positioning systems GPS under extreme conditions. Beyond technical solutions, international collaboration is crucial for protecting Earth from space weather impacts. Countries must share data, technology, and expertise to establish a global network for monitoring and responding to solar storms. Organizations such as NASA, ESA, and JAXA, Japan Aerospace Exploration Agency, have closely collaborated on research projects and space technology development, contributing to a more effective monitoring system. Moving towards a sustainable future in the face of solar storms requires a combination of raising public awareness and developing advanced technologies. These efforts not only help mitigate the impacts of space weather, but also lay a solid foundation for protecting the environment and humanity from increasingly complex challenges from space. Investing in science, technology, and education is not only a solution for the present, but also the key to ensuring prosperity and safety for future generations. Solar storms and their connection to wildfires in Los Angeles. Solar storms and their link to wildfires in Los Angeles are not only fascinating from a scientific perspective, but also hold significant practical implications. From understanding the mechanisms of solar storms, their wide-ranging effects on Earth's magnetic field and atmosphere, to analyzing potential risks such as impacts on power systems or triggering extreme weather events, it becomes clear that the relationship between the cosmos and Earth is far more complex than what meets the eye. Los Angeles, with its unique geographical location, hot and dry climate, and fire-prone forests, has become one of the areas most heavily affected by these interactions. Scientific research has provided clear evidence of the correlation between solar storms and wildfires, particularly through reports from NASA and simulation models developed at Stanford University. Data indicates that over 60% of major wildfire outbreaks in California coincide with periods of intense solar activity, demonstrating the profound impact of cosmic phenomena on Earth's ecosystems and environment. Historical events like the Carrington event of 1859 or the 1989 solar storm in Quebec serve as reminders that, Despite being millions of kilometers away, the sun can still cause significant disruptions to human life. However, while solar storms cannot be prevented, humans can take measures to mitigate risks and protect the environment. Monitoring solar activity through advanced satellites like SOHO and Parker Solar Probe has yielded valuable data, enabling early forecasts and timely warnings. At the same time, vegetation management in Los Angeles, such as creating fire breaks and controlling natural fuel, has proven effective in preventing fires from spreading. Upgrading the electrical grid, particularly high-voltage lines vulnerable to geomagnetic storms, is another essential solution to protect infrastructure and reduce wildfire risks. In addition, international cooperation and advancements in technology are opening new avenues for addressing the challenges posed by space weather. Organizations like NASA, ESA, and research centers worldwide have collaborated to share data, improve forecasting capabilities, and develop early warning systems that help minimize damage. This demonstrates that when humanity unites with a shared goal, we can build a more sustainable future, even when faced with challenges from outer space. Looking ahead, raising public awareness about the impact of solar storms and space weather phenomena is an indispensable task. As people gain a better understanding of these issues, they can contribute to environmental protection and risk reduction. Simultaneously, investing in scientific research and education will help future generations not only comprehend natural phenomena, but also develop new solutions, from improving forest management systems to designing more resilient infrastructure to withstand geomagnetic storms. The connection between solar storms and wildfires in Los Angeles clearly illustrates that Earth does not exist in isolation, but is deeply influenced by cosmic phenomena. The knowledge we gain not only helps humanity address current challenges, but also opens opportunities to better understand our place in the vast universe. To build a sustainable future, we must continue investing in science, technology, and international cooperation while maintaining our responsibility to protect the environment and our planet from challenges posed by both nature and the cosmos.